Imagine you're debugging a massive system, a cloud infrastructure, a research paper tracker, or even a financial market, and every action is logged in a table. These tabular logs track objects, events, and changes over time. But how do you spot anomalies when the data is messy, evolving, and full of text? Traditional methods either rely on rigid domain-specific rules, which don't scale, or heavy large language models, LLMs, which are slow and expensive. Here's a smarter way: GraphLogDebugger, a new framework that treats tabular logs not as static tables, but as dynamic graphs. Each object, like a company, a block ID, or a researcher, becomes a node. Each event, a stock trade, a log message, a paper submission, becomes another node. And every connection between them, an edge timestamped, evolving over time. Now, instead of running complex LLMs, we use a lightweight dynamic graph neural network, GNN, to predict whether new connections make sense. If the model says no, boom, anomaly detected. Why does this work better? Because the graph captures context. It remembers past relationships. It knows that if a researcher has always worked on AI, a sudden connection to a quantum physics paper is suspicious. And it does this in real time, with 500+ predictions per second, way faster than LLMs. We tested this on real-world datasets: system logs, academic papers, financial news, landslide reports. In every case, GraphLogDebugger outperformed LLMs in both accuracy and speed, even in complex text-rich environments. The takeaway: you don't need a giant model to understand complex systems. Sometimes all you need is a smart graph. This is the future of log debugging: lightweight, scalable, and powerful, built not on brute force AI, but on structure, logic, and dynamic reasoning.